Hello everyone. In this video, we are going to discuss the question fruits in the basket, and it is very much like the questions we are just discussing in this playlist. So yeah, just go to the question. We are visiting a farm that has a single row of fruits arranged from left to right, and we are given a fruits array where fruit of I is the type of the fruit in the type of fruit the ith tree produces. Like we are given the type of fruits. Okay, now we have only two baskets, and one basket can store only a single type of fruit. Like if a basket is storing a fruit of type 1, it will store only the fruits of type 1. And if a basket is storing a fruit of type 2, it will store only a fruit of type 2 and so on. Okay. Now we can pick the tree of our choice, but we can pick exactly one fruit from every tree. Like at ith index, we have a tree. Now from every tree, we can get only a single fruit. Now we need to tell that what is the maximum number of fruits we can pick. So just see how we will identify that this is a question of sliding window. So in this question, what we are given is we are given an array that contains the types of fruits. Okay, so the array, let's suppose it is something like this. Let's suppose I put 210 over like this. Okay. So once you start picking fruits, you need to pick fruits in like order. You need to pick fruits from left to right. That is, you need to pick continuous fruits. So once this words comes, continuous fruits you need to pick. So yeah, you just think of something like subarray, contiguous elements. So once the word subarray comes to your mind, the word approach sliding window should also come, isn't it? ऐसा बोला है ना कि like we if we start to pick, we can pick 0, we can pick 1, we can pick 0, then if we have an option we can pick 2. It is not like all 0 का pick कर लिया यहाँ से यहाँ से यहाँ से यहाँ से. This is not the case. We need to pick the continuous elements, isn't it? So yeah, that's from there the word sliding window, the approach sliding window comes to our mind. Now the question is how to solve this. See, we are given that we can take fruits only of type 2 types. So maximum types allowed is 2. So yeah, we discussed this type of question in before also, isn't it? Like using a map, we can store the frequency of an element. If the element comes for the first time, this means it increases the value of count, that how many times the frequency like a element has come. Now, if that element goes to 0, this means that that element is not present in that window, isn't it? Like if we have a window and first time if we encounter 1, uh, at this point of time, the value of m of 1 will be 1, isn't it? What does this mean? This means that 1 has occurred for the first time in this window. So we will increase the value of our unique elements. This is the approach we follow, isn't it? Like we store the number of unique elements in the window. Now, if the number of unique elements exceed the value of 2, this means this is not a valid window. And if the number of unique elements is less than 2, this means that this is less than equals to 2. This means this is a valid window. So if the number of unique elements in the window is less than equals to 2, this implies it is a valid window, isn't it? So yeah, हम लोग यूनिक एलिमेंट्स मेंटेन करने के लिए क्या यूज कर सकते हैं? मैप यूज कर सकते हैं. Once the elements come for the first time, the count of the unique elements will increase. And once the element goes to 0, like while we are forwarding our I, like जब I को forward कर रहे हैं, and once its frequency becomes 0, this means the count of unique elements decreases. Okay. So yeah, this is the approach. Let's dry run for one of the codes and then we will code it down. Let's suppose we have an array as 1, 2, 3, 2, 2. 1, 2, 3, 2, 2. Okay. So initially the value of count is 0, like the number of unique elements we had is 0. We have I over here and j over here. Now first of all we come to 1. We will use a map to store the frequency. Now first of all we come to 1. If we come to 1, we will see, we will just increase the frequency of 1. What we will do? We will do MP of 1 plus plus, isn't it? After doing this step, the frequency of 1 becomes 1. What does this imply? This implies that 1 has come for the first time in this window, so the value of count will also increase. Okay. Now once we are done with this, we will check that if the count value of count is less than equals to 2. If that is the case, so yeah, we can, like, this is a valid window and we can just store it in our size. Now we come to 2. We shift our j, we come to 2. Now once we come to 2, we know that okay, mp of 2 plus plus. Now we see that this is the first time 2 has come, so the value of count again increases. The value of count becomes 2. And okay, this is also a valid window because the value of count is less than equals to 2. Why we are doing less than equals to 2? Because we have only 2 baskets, isn't it? This basket can store the fruits of one type and this basket can store the fruits of one type. So the number of unique elements in the window, which is a valid one, should be less than equals to 2. Okay. Now we come shift our j over here. We increase the value of frequency of 3. And now the frequency of 3 is also 1. So in this case, we increase our count from 2 to 3. But this is not a valid window, isn't it? So in that case, we need to shift our I. While shifting our I, what we will check is, first of all, we will remove the contribution of ith element. So what we will do? We will do mp of like nums of I minus minus. So while doing this, we will do mp of 1 minus minus, isn't it? Like the ith element is 1. So once we do this step, the value of mp of 1 becomes 0. What does this imply? This implies that in the remaining window, 1 has not come anymore. So the count of unique elements reduces by 1. So the count of unique elements becomes 2. So once it becomes 2 and the value of I gets forwarded over here, we can clearly say that this is a valid window since the count of unique elements is less than equals to 2. So yeah, this is a valid window. Now we shift our j. We increase the frequency of 2. So initially the frequency of 2 was 1. Now it becomes 2. But since it is 2, does it imply that this is the first time it has come in this window? No, isn't it? Like before भी आया है. कैसे पता चल रहा है कि frequency 2 का 2 है? इसका मतलब वो पहले भी आया है. So in this case, we will not increase the frequency of unique elements, and this is also a valid window. Then we shift our j over here, and again we increase the frequency of 2. Again, we frequency of 2 becomes 3, which is greater than 1. This means that it has occurred before also in this window. So yeah, we will not increase the count of unique elements, and this is also a valid window. So what is the maximum size window we got? That is our answer. Because from every tree, we are picking one fruit. So if we have a window of size 4, we will pick a maximum of 4 fruits. So yeah, 4 is our answer. So this is the approach. Let's code it down once. First of all, we will store the count of unique elements. Let's suppose it is 0. And we will have an I for sliding window, which is initially 0, and j, which is also initially 0. And we will have n initialized to fruits dot size. Okay. And we will have a map which will store the frequency of elements. Now we will run the loop till the maximum value of j. We will take the contribution of jth element. Okay. Now if the frequency is 1, like once we took the contribution, we will check that if the frequency is 1, what does this imply? It is the first time it has come in this particular window, so the value of count increases. Now what we do in like a variable size sliding window, we just check the condition that if the value of count is greater than the maximum permissible value. If this is the case, we will shift our I. But till when we will shift our I? We will shift the maximum value till we can shift our I is equals to j. So while I is less than equals to j and the value of count is greater than 2, we will shift our I. In this case, first of all, we will remove the contribution of that ith element, mp of fruits of I minus minus. And once the frequency of this element becomes 0, what does this imply? That this element is not present anywhere in this remaining window, and hence the count of uniqueness of elements decreases by 1. And we will simply shift our I. Now once we are done with this, we will come out of this if condition. And we will simply do like we can store an answer. Initially, the value of number of fruits we can pick is 0, and we can do as answer equals to, like, this is a valid window from I to j. So answer equals to max of answer comma j minus I plus 1. And at the end, we can return our answer. That is the maximum number of fruits we can pick. Let's try to run it once. Okay, it's giving us a TLE. Okay, we didn't shift our j over here. Okay, it got accepted. Let's try to submit it. Okay, it's working fine. So I hope you all got this approach, and you all are now very much comfortable with the sliding window approach. It's very helpful in solving many of the problems. Okay. So by then, thank you. Keep watching.